Okay, today we're going to look at completing the square. So we're going to do a bit of a revision on this. I know I didn't teach you this topic, so I'm going to go through how I would do this. I'm going to talk to you as if you don't know about this. So if you do remember it, just bear with me while I go through some of the basics. So a complete square is when we're looking at factoring, remember we're looking for two numbers that add to the middle term and multiply to the last term. So that add to the middle, multiply to the last. But in a perfect square, they're the same number. So in this case, they're both 3, right? So when we look for two numbers that add to the middle and multiply to the last, if they're the same, it's a perfect square, and we can write it like this. So there is a reason for this. It's not just for funsies. The reason that we do this is because it gives us the turning point of a graph. We're not going to address that this video. I'm just going to show you how to do it, and then we can look at interpreting it for graphs at some other point if you need that too. So what we're going to do is recognize that this is a perfect square, and then I'm going to say, okay, let's have a think about this. So what belongs here? If this was a perfect square, what number would go here? So what two numbers are going to add to the middle term and multiply to the last? So what two numbers add to 12? Hopefully you can tell that that's 6. So then they have to multiply here. So really what I'm doing is I'm taking half this term, then square it. Right, because I want to get half of this because 6 plus 6 is 12, and then I need to square 6 because 6 times 6 is 36. So that's always what we're doing. We're going to take the middle term, halve it, then square it. So same thing for here. We're going to halve negative 16, so we end up with negative 8, and then we're going to square negative 8, which gives us positive 64. Now, if this is a perfect square, this term always has to be positive, right? Because even if this is a positive or a negative, it will always square to a positive number. So that's one of the ways that you can sort of check what's going on here. Right, so, obviously it would look like this, right? If we actually factorized it, x minus 8 squared, right? So that's what it would look like if we factorized it. Okay, so what we're going to do now is we're going to solve this by completing the square. So what I'm going to do is I'm going to say, if this was a perfect square, what would it look like? So x squared plus 10x, something goes there, right? So again, I'm going to halve this term and square it. So halve it is 5, square it is 25. But I can't just do that, can I? Because now I've changed the whole equation. So whatever you do to one side of the equation, you have to do to the other. So I'm going to add 25 to both sides to balance out my equation. So that makes this x plus 5 squared, right? This is my perfect square. Then this side is 28. Now, in terms of solving, there are, you can just move it around, right? So you just do exactly what you would do to undo a normal equation. The opposite of squaring is square rooting. And then I need to get x by itself. But remember we have to do that. Let's talk about that. Okay, so for the same reason over here, I can't tell, if I square a number, I can't tell whether it used to be positive or negative, right? Because, let's write it down here. So 3 squared is 9, and negative 3 squared is also 9. I have no idea. If I take the square root of this, I don't know in reverse whether it used to be positive or negative. So that's why we're saying when we take the square root of the other side, it could be positive or negative. So then I get two different answers. These are actually my x-intercepts. Hopefully we remember that if we're solving for x. In this form, let me just rewrite this a bit. So x plus 5 squared minus 28 equals 0. If I just rearrange this, this is your turning point formula. I'll go through that some other time. Don't worry too much about that at the moment. I'm just looking at solving it. So this is how we do it by completing the square. Let's do it again. The first thing I'm going to do, so this already had the 3 over here. I'm going to move this first to get it out of my way. Plus 8x, something goes in here. 0 plus 20 is just 20. So now I'm going to complete my square. So I had to do an extra step on this one because I had something in the way. So x squared, halve it and square it. Half of 8 is 4, squared is 16, equals 20. And then if I add 16 to that side, I have to add 16 to this side. Okay, so let's have a go at solving this. So then that means x plus 4 squared, and this is 36. Now, the good thing about this is we're going to get a nice actual answer, as opposed to this, which is some crazy decimal. We don't really want to round unless we're told to. This is a perfectly fine solution. This is the answer. If you're told to give decimal places, do, but otherwise just leave it like that. But for this one, we can tell the square root of 36. We know that's 6, so we're not going to get decimals this time. So equals plus or minus the square root of 36. So then x equals plus or minus 6 and then minus 4. So then we can get two answers from this. So plus 6 minus 4 is 2. And then negative 6 minus 4 is negative 10. So I have two actual whole integer answers for this one. So that's how you complete the square. You just design something, but whatever you do to one side of the equation, you have to do to the other. This thing we'll talk about later, but this is just undoing equations. But don't forget to take both the positive and negative square root, because we don't know what the answer used to be. And these are the two x-intercepts of your graph. If you graphed this, that is what you would get as your x-intercepts. Okay, let me know if you need a hand. With that, I can go through more examples, but that is just a quick rush through of completing the square. Hopefully it is revision and this is all ringing a bell. All right, get in touch if you want some more help.